Okay, well, people are slowly wandering back in. A lot of good networking going on out there. I met a new company I was not familiar with before, and I'm going to follow up with them about a potential manufacturing opportunity in Pierce County, which is always a good idea. Always think about investing in Pierce County, Washington, the best place in the world to do business, as you all know. Yay. All right, so I'm watching people continue to wander in. I think with that, we'll go ahead and get started on our 11 o'clock panel, Regional Considerations for Using Reclaimed Water. I'm going to introduce the moderator, and then she will walk us through the introductions of the other panelists. Lorna Mallory and I have known each other for some time. She's worked on all of our Wellsprings with us in the past, this being the third year, and is one of the key professionals in this market in the clean water space. Her current position is as Environmental Services Assistant Division Manager in the city of Tacoma, and that's one of our sponsors for this event, so we do appreciate that. She's been at her work in this field for more than 25 years, and included stints in the public and private sectors. She's led work groups that have developed and implemented vital stormwater programs and policy, and completed a wide range of capital projects. So she has deep experience and deep knowledge of this industry, and is particularly well suited to moderate this panel. So with that, I'm going to turn the microphone over to Lorna. Please join me in welcoming her.
Good morning. Welcome to session 2. The first session, we heard from some water utilities, and in this session, we are going to move to the post-consumer side and hear about how to best manage reclaiming some resources from various waste streams. So up first is Jim Parvey from the city of Tacoma. He's a senior principal engineer. Hang on here. Jim has 27 years of experience in the civil and environmental engineering field. He holds a bachelor's degree in civil engineering from UW. He's a licensed professional engineer in Washington, an accredited professional with the U.S. Green Building Council's Leadership in Energy and Environmental Design program. At the city of Tacoma, he works with the state, community groups, and others to develop a rehabilitation program and secure funding for the Murray Morgan and Hylobos movable bridges. He's worked both for public and private enterprise, and his project experience includes the Center for Urban Waters, yay Jim, the Hylobos Bridge rehabilitation, public-private partnerships, and other alternative project delivery methods. So, Jim.
Well, good morning, everybody. It's really a pleasure to be here. It's exciting to be at the 3rd annual Wellspring, so I think we can call ourselves an annual event now. So almost the whole time I've been working as an engineer in the environmental field, you always come into the jobs versus in clean environment. So you can have clean water, but you can't have jobs, or you can have clean air, but you can't have jobs. And so the project I want to tell you about may help dispel that notion, and maybe we need to think of the tension between the environment and the economy as more of a challenge to our human creativity than it is an observation of actual conditions. Before I get started, there's a few people I'd like to thank. We couldn't have done the pilot study without the help of our friends at Brown and Caldwell and Kennedy Jenks, as well as Incinerator. Their contributions allowed us to move forward on this project and actually bring the pilot study to conclusion. First question, anybody here work for the government? Anybody? I'm all on your side, it's okay, I won't go after you or anything. Anybody been here for the government more than 5 years? More than 10 years? Okay. So in all that time, have you guys learned to love lemonade? Because what I find is that day after day, we're handed more and more lemons that we need to figure something out to do with. What's in front of you is a series of challenges that we've been facing at the Environmental Services Department. It consists of 3 utilities: a surface water utility, a wastewater utility, and a solid waste utility. And these are all problems that probably as individual utilities we can't solve, so we had to work together to figure out how we might get a handle on these. One piece of good news, the second one from the bottom, the Tacoma Air Quality Non-Attainment Zone, it looks like we're moving past that. A few weeks ago we got word that we're being taken off that list. But the basic facts that we're still dealing with is our central wastewater treatment plant was designed during an era when there was a lot of food industries in town. Since the plant was built, we have lost a dairy, we lost a chicken farm, and of course we lost Nally Foods as a food producer. And what that's done is left us with a plant that was built for way more waste than we're seeing, so we have some challenges in operating that plant effectively. One of the things that we're also dealing with, and I'm sure you all are, is that fuel costs, although we've seen a little break lately, they tend to rise, they tend not to come down, and especially in our solid waste utility, we use a lot of fuel. Our solid waste management utility is tasked with reducing the amount of waste that goes to the landfill by 70% in 2028. So that means by 2028, every 10 pounds of garbage that comes into the city is managed by the city. 3 pounds can go to the landfill, and we have to figure out what to do with the other 7 pounds. And then the last thing is that our city council is very environmentally proactive, and they signed a resolution on our climate action plan, which directs staff to figure out ways to reduce our greenhouse gas emissions. So this slide is sort of my Rorschach blot of how we might solve this problem. There's probably 3 things I want to leave you with on it. Is there a laser on this? Anyways, so there's 2 fronts we're using to attack the problems that I listed before. One is trying to figure out how to harness the energy in commercial food waste and, use it for good. The other tack is to use more of a distributed system, and rather than collecting it, we would have the individual homes manage that solid waste by using food waste grinders and also sending it to the plant. So I don't know how many of you are wastewater folks, but one of the products of wastewater treatment, of treating the solids in wastewater, is that you get methane gas. As the bacteria break down the food waste, the organic waste, it releases methane gas, which is also known as natural gas. And for most of the presentation, I'll call that renewable natural gas. So if you hear me say renewable natural gas, it's the exact same gas that you get from PSC or any other pipeline. It's just that it's coming from a treatment plant. So what we would like to do with that to manage our fuel costs is convert our fleet to run on compressed natural gas or renewable natural gas, and there's some cost advantages to that. And so the other takeaway from that is we're sort of brought up to be waste management people. That's what we were trained in, waste management, but we need to turn the corner and think of ourselves as resource managers. So the basic theme is to capture methane or renewable natural gas and use it as a vehicle fuel, take food waste away from the landfill and put it into the treatment plant. We have excess capacity at the treatment plant so we can take way more food waste than we have access to at this time anyways and treat it, and then over time convert the city's fleet to run on renewable natural gas, a fuel that we can produce ourselves. Just by way of information point, the amount of gas we produce at the treatment plant is equivalent to about 200 gallons of diesel per day. So that's enough to run about maybe 10 to 15 garbage trucks a day. This is a chart from the Energy Department that projects fuel prices out through 2040. And so the top grouping there is basically the hydrocarbon-based fuels, the resource-based fuels, and then the lower tier is, the bottom two are renewable natural gas, and the one above that is the price of natural gas that's expected. So you can see that there's quite a cost advantage in going with natural gas or renewable natural gas product. One of the things that is really important to a utility, we have to plan out, and so we like certainty in things. You know, we like to know what's happening in 20 years so we can build a rate to deal with that. And if we can put online our own system of developing fuel, we sort of locked in our price for fuel over time because we've bought the capital equipment. We know the cost of production of the methane itself is a byproduct of the treatment process. So we've locked that in. It lets us do better predictions in the future. One other thing of interest that I didn't include in that chart, and we haven't included in the economic analysis we've done on the project, is a thing called a renewable identification number. And basically what that is a credit that EPA requires hydrocarbon fuel-based companies to buy to offset the hydrocarbons that they're using as a fuel. It's sort of a volatile number. A year ago, if I was given this talk, I'd be telling you that a RIN was worth over $2 per diesel gallon equivalent. Now it's down to about 50 cents per diesel gallon equivalent. Because of that volatility, we didn't include it in our business case analysis for the project. And that's only available, by the way, if the fuel that we produce is used as a transportation fuel. It can't be used for heating the plant or to generate electricity unless you could show you were using electric vehicles, I suppose. So the business plan's kind of simple. We'll divert waste from the landfill and process it at the plant. I think environmental services, we're good at running plants and stuff. We're not really good at retailing services, so we would like to position ourselves as a wholesaler and vend our fuel to a private distributor to retail the fuel. We could also use that facility or that company to fuel our vehicles as we do now. We use a card lock system to fuel our vehicles. Use the RIN credits to help offset some of our costs, and again, use a public-private partnership to vend the fuel. So like everything, it sounds really great when I'm talking about it, but sometimes there's some details that have to be worked out. The picture in the upper left shows what happens if we put waste into the treatment plant that it doesn't like. Essentially, it foams and blows stuff out of the top of our digesters. Nobody likes that. So one of the things the wastewater folks wanted me to demonstrate to them is that our food waste would not upset the treatment plant. And most importantly, if you're from Tacoma, you've probably heard of Tagro. It's our biosolids product. It's a soil amendment. It's a Class A biosolid, so you can use it for almost anything, growing food, landscaping. And in fact, we received a letter from the White House a few years ago asking for 10 gallons of Tagro that they could use in their herb garden. They had heard about it from one of their chefs who worked in this Northwest and had used it in his job previously. So I don't know too many sewage plants can say their biosolids were sent to the White House on request. Solid waste also had some concerns, so they're used to handling garbage and putting it in a transfer station and sending it to a landfill. This is a different operation. They're trying to run some equipment that's unfamiliar to them. Garbage is a difficult material to manage and handle in any case, and food waste, when you're separating it out, if you let it sit too long, it can get rancid and smelly and attract varmints, so it's a little bit more of a challenge to handle than your everyday garbage. So we decided that what we needed to do was a pilot study and work out some of the bugs and demonstrate to folks that we're not going to upset the treatment plant, we're not going to interrupt solid waste operations. We wanted to see if the treatment plant could treat it, of course, and most importantly, make sure that we didn't adversely affect Tagro. So here's what our market looks like a little bit. We have up to 1,000 commercial food waste generators in Tacoma. We have 65 participating in the pilot program. And in that program, the city provided the containers you see in the lower right there. And we collected about 10 to 12 tons per week. And just so you know, the treatment plant treats about 20 million gallons, between 10 and 20 million gallons of water a day. So this is a very small amount of material going to the treatment plant. And one of the things we wanted to do everything we could to make sure we were successful in our first initial try. So we The food waste you see in the upper left, this is all pre-consumer, so it's stuff from the grocery stores, that vegetables that had sat too long. We kind of call it the Cohiba of food waste. If you like cigars. This is a picture of the equipment that we're using to process the food waste at the landfill. Basically, towards the back of the frame there, you'll see the hopper for the machine that's loaded with a bobcat. There's an auger underneath that transports and sizes that a little bit, crushes it up, chews it up a little bit into that vertical tower there. And the vertical tower has that auger and screen system in there. We add water, and that auger forces material through the screen and sizes it, so it's fairly small by the time we're taking it to the treatment plant. Interesting thing, it turns out pumpkins don't really process very well. In fact, they kind of shoot up the chute and fly out that hopper and go bouncing across our transfer station floor. So that's what's nice about pilot studies. You learn something new every day. This is a picture of the operation of it. There's some economies of scale if we decided to keep going with this, that we changed that hopper. It's so small that it required constant attention by the bobcat operator, so that hurts the economics of it. We have too much operator time on it. So to cut to the chase, the results, no adverse effects on TAGRO. We found that a ton of food is about the equivalent of 13 gallons of diesel. It's biogas, but the energy equivalent. We didn't have odor problems that we couldn't manage. One of the things with the plant being too big for the flows that come to it, it gets hungry on the weekend, if you will. There's not as much flow going to it, so there's not enough nutrients to support all the biological activity. And so we found that by loading the digesters on a Thursday or a Friday, that helped the plant run better over the weekend. Fibrous organics such as pumpkin should be excluded from the program. And actually, the pilot was so successful that what we want to do is modify the equipment that I showed you in the previous slides to go to a year-round operation, so that would include some freeze protection, bigger hopper, and some other changes. And probably the best result of it is when we were done with the process, I was talking to one of the operator supervisors, and I said, well, how'd it go, Tony? And he goes, well, the plant likes it. So that's good enough for me. I'd like to switch over now and talk about the residential food waste disposers. We did if you're familiar, we had a Healthy Homes, Healthy Neighborhoods program that we did last year, where we targeted one area of the city and kind of pushed the services, environmental and sustainability services that are available. One of the things we did is we worked with InSinkErator to provide food waste disposers to the residents if they wanted them, and part of it was they had to participate in the study and keep some records. We did some sorting and weighing of their trash before we started to figure out how much of it was food waste. And then we installed 70 food waste disposers in that neighborhood, and then we would track how much waste they were generating, so we'd weigh it each week as we bring it out just to see what's actually happening with the amount of waste being produced. And so what we found is that the overall food in the waste stream for the neighborhood decreased by 3.2%. That's a pretty good number, really. And food waste in the garbage of actual participating households decreased 14%. So that's moving the needle quite a bit for people who adopt it. And that's a big step towards getting us towards our 70% diversion. It's a big deal. We also did a survey of the participants afterwards, and 78% reported no problems. Problems that were reported, most common was jams and clogs. And there's, I did this too when we remodeled our kitchen. I got a food waste grinder, and so there's a temptation just to see what all can go in there. And so I found ham bones not so good, avocado pits are awesome, corn cobs maybe not, but the way you find out is you jam the machine, and then anyway. One of the concerns we had with the process is we don't like fats, oils, and grease going down the drain because it lines the inside of our pipes and kind of causes sclerosis, difficult word for me to say, and narrows the pipes. What we found based on the survey is people were not using the food waste grinder to handle the grease. They were still doing it and dumping it in the trash as we asked them to do. 90% were satisfied. That's really good. Usually, from what I've seen in government, if I can get half of the people happy with what I'm doing, it's really a good good day, 90% is outstanding. And 60% we're using the food waste disposer almost for every meal and cleanup. So those are all really good numbers, and so we're seeing that can move the needle for our diversion goal. So those are the two tracks to try and get more biogas produced. Then we need to figure out what to do with it. And so in September, we submitted a grant request to the Commerce Department to help defray some of the costs of purchasing the equipment, the biogas scrapping equipment that would allow us to turn our methane into fuel. Our solid waste utility is in the process of converting their fleet over to compressed natural gas. We're just finishing up the filling facility at the landfill. That should be online first part of next year, about the same time that our first CNG trucks show up. We expect that we'll have our bio-CNG or our bio-renewable natural gas scrubbing facility online in the summer of 2016 so that we can start manufacturing our own fuel. And currently, whenever our fleet orders new vehicles, they order the dual fuel option on them, so they can either run on diesel or gas or have an option for natural gas power. And the scheme is that as our existing vehicles come to the end of their life cycle, we'll replace them with a CNG, or we might also be looking at some other diesel hybrid variants also. But the goal is as a vehicle that comes to the end of its useful life, we'll replace it. So here's what we hope to see happen for our rate payers. We hope to keep the rates low by reducing our fuel costs, developing a new revenue source for our utilities, better utilize our plant infrastructure, divert more material from going to the landfill, and then we also think that we should see a benefit of greater resilience for the utility by diversifying our fuel source. So we'll also have an on-site availability of fuel should a disaster strike. It helps the environment. We're going to put less stuff in the landfill. We're offsetting greenhouse gases producing fossil fuels with biofuels. We'll have reduced air emissions. Biogas, natural gas has far fewer particulates and generally runs cleaner than diesel fuel. And it helps build Tacoma's reputation for green innovation. So that's the end of my presentation, and I guess we'll take questions at the end. Thank you.
Awesome. Okay, the next presentation, there's two gentlemen from Kennedy Jenks. They're going to do a straight man, funny man routine here. Anyway, Chris Stoll is a civil engineer working in Seattle. He works on drinking water, recycled water, wastewater treatment, distribution, conveyance, stormwater management projects in Washington and Oregon. And Mark, who is Mark Cullington from Portland, is principal scientist and operations manager. Mark works on reclaimed water planning and design projects throughout the West Coast with a focus on Western Washington and Oregon. So welcome.
Great. Well, good morning. Thank you, Lorna, for the introduction, and thank you to Jim to invite us to speak at this. We're excited to be here. As Lorna said, my name is Chris Stoll. I'm with Kennedy Jenks, and I'll be co-presenting with Mark Cullington. I'm going to switch microphones. Can everyone hear me? Perfect. Great. Well, today we want to talk to you about reclaimed water, what that means, and how it's a valuable resource. So just an outline of what we're going to go through today. We're going to talk about some different types of water that you'll commonly see in the utility industry. We'll talk about the definition of reclaimed water. We'll talk about the treatment process that reclaimed water must go through. We'll talk about the drivers for using reclaimed water and then what you can actually use the water for. And then at the end, we're going to talk about a couple case studies in Washington, so there's some local flavor to how reclaimed water is being used and what the drivers are here. So some different types of waters that we deal with in the utility industry. First is drinking water. This is water that comes out of your tap that is fit for human consumption. It meets strict standards set by the EPA. The next type of water that we might think about is gray water. And gray water is typically water that's reused within a home itself. And this would come from sinks or showers, and the water would be stored, might go under some sort of light amount of treatment, and then could be used for things like irrigation or toilet water flushing. The next type of water we think of is rainwater harvesting. This typically comes off of roofs from commercial buildings or residences, and this is typically used for irrigation. It's collected in rain barrels, similar to the one shown here. And then lastly, there is reclaimed water, also known as recycled water. And this is highly treated domestic wastewater that is safe for many, many uses that we're going to talk about further. And it also meets strict standards that are set by both the Department of Ecology and the Department of Health here in Washington. So the definition of reclaimed water, the revised Code of Washington defines reclaimed water as any water derived in any part from wastewater with a domestic wastewater component that has been adequately and reliably treated so that it can be used for beneficial purposes. So this is the water that you flush down your toilet, that goes down your sink, anything that ends up in the sewer collection system and then is held to a high standard of treatment at a wastewater treatment plant. And just so that we can get kind of on the same page, the terminology, you'll see recycled water, you'll see reclaimed water, and you'll see reuse water. And in Washington State, we use reclaimed water, so we're going to continue with that term throughout our presentation. But if you see reclaimed water or recycled water, or reuse water, these are other terms that are commonly used in California or Texas for the same type of water. So we're going to talk a little bit about the treatment process that reclaimed water goes through, and I'm sorry, this is for all the wastewater nerds out there like myself, so bear with me on this one. First, there's a collection system, and this takes sewage from mostly residences or industrial processes. And there's also stormwater that ends up in the collection system and ends up going to the wastewater treatment plant. And at the plant is really where all the treatment takes place before distribution of reclaimed water. So the first step is preliminary treatment, and this is mostly removal of solids, such as a screening process, grit removal, primary clarification, anything like that. The second step is a secondary treatment, and this is actually a biological process in which we remove organics through the use of microorganisms and bacteria. This is usually done in an aerated process or an anoxic process. And then typically when we think about wastewater and discharge, this would be the point where we discharge to a receiving body. So this would be a river or a lake or the Puget Sound or the ocean, those kinds of receiving waters. But reclaimed water has to go through additional steps in order to meet the strict standards that it undergoes. The first is tertiary treatment, and this is usually some sort of filtration done with membranes or a media filtration, and this acts as another barrier to public health and allows the water to be cleaner. And the last step is disinfection, and this is for removing and inactivating any sort of remaining bacteria and viruses that is in the water, which would potentially make it unsafe for uses, as we'll see. So now I'm going to hand it over to Mark to talk about the drivers for reclaimed water.
Good morning, everyone. Now that we know what reclaimed water is, and folks still hear me well? Okay. We're going to talk about, well, why do this with reclaimed water? Why do we want to reuse this resource? Well, globally, there are a lot of drivers. Primarily the driver globally in places like Asia and Australia, where there's quite a bit of reclaimed water usage, it's due to lack of potable water supply. For example, in Taipei, Taiwan, they actually do direct consumptive use. It comes from the treatment plant right to bottling facilities and right to actual faucets, and it's consumed directly. In Texas, we have the first one of its kind that went online earlier this year. That's rare in North America. It's becoming less rare in places like Australia and other parts of Southern Asia. In the United States, there are several states that actually implement reclaimed water programs. The blue section here that you see on this map are areas that primarily are what we reflect as droughty areas, areas that lack potable supply water. Now in Florida, the primary driver, and the reason why it's used and it's highlighted here is a couple of primary reasons. In southern Florida, groundwater is very, very, very shallow. The access to that potable supply is difficult, and there's a lot of demand for non-potable uses for irrigation, wetland enhancement, and industrial commercial uses. Here in the Northwest, there's been active reclaimed water programs for 40 years. Our treatment plant operators and managers have been generating reclaimed water and using it for in-plant uses at their treatment plants, both for in-process uses and landscape irrigation of their lawns throughout their facilities. We're seeing a growing use here in the Northwest, in particular in Western Washington and Western Oregon, and the primary reason is discharge permit requirements. So this is a little bit unique to the Northwest in other areas that have fairly restrictive discharge regulations. When I refer to a discharge regulation, that refers to the permit that a wastewater treatment plant has, typically referred to as a National Pollutant Discharge Elimination System permit, that governs how that effluent is treated at a treatment plant and ultimately discharged, typically to a river or aquatic environment like the Sound. These standards are becoming more and more stringent to protect things like cold water fisheries, salmonids, etc. So a lot of our treatment plant operators and managers are looking toward a different use for this beneficial water. And also treatment processes have improved over the years, and the long-term use of reclaimed water in other parts of the country have shown that it can be done and be very protective of human health and the environment. And so that would be the primary driver that we see in Western Washington. So a little bit more on the regulations, because again, this is a primary driver, and we're just really seeing this coming into Western Washington with really what I would say are far more stringent standards than we have seen in the past. Both around nutrients, a little bit on toxics, temperature as well. Temperature is a pollutant. It's a major driver for discharging treated effluent into rivers, and that is probably the primary driver for our decision makers at municipalities when they think about doing something. They need to do something different with their discharge permit. Total maximum daily loads is a process that the EPA and the State Department of Ecology use to assess ambient water quality, and then come up with standards and regulations that are specific to a certain watershed. Typically those TMDLs are really focused on our wastewater treatment plants, not so much on what we refer to as non-point sources, which are, let's say, irrigated agriculture, forestry, and the such. So municipalities, I would say, bear the primary burden of implementing those TMDLs. And then there's active litigation. This is ramped up full speed in the past 7 or 8 years here in the Northwest. As standards come out, as the state regulatory authorities develop standards, they're litigated, and that has resulted in a tremendous amount of uncertainty for our municipal facilities. Lastly, on the regulatory front, the state of Washington has actual regulations in statute, which typically has resulted in them being interpreted in a very black and white methodology by our state regulators, as opposed to it being in a regulation. Now, Ecology and Health just this year have picked up the regulation. They were revising it a few years ago, and then it was put on hold. They've picked it up again, and they're aiming to modify those regulations, take them out of statute, put them in state rule, and hopefully with a goal of having this water actually be regulated as a resource and not necessarily as a waste. And that has been somewhat of a trend in regulations, and it's embodied in the implementation of the Clean Water Act. So that's the goal, and I know Ecology and Health are working on this right now and hope to have rules out in draft rules within the next couple of years. So there's a lot of uses going on with reclaimed water here in Western Washington. Irrigation is probably the primary use, followed by some industrial applications, a little bit of toilet flushing, which would be in the commercial use category. There's wetland enhancement, so not only primarily for the creation of human-made wetlands, but also for augmenting actual existing wetland facilities. Groundwater recharge, actually, Lot Alliance has a bit of this, and they have for many years, where they do a little bit of recharge. And then stream flow augmentation, a little bit complex, but essentially, if you think of a river system, most of what you see on most rivers, the actual river, you're seeing a very small portion of the actual river system. Most of the river system is underneath that surface water in what we call the hyporheic zone. And there's some planning and actual projects that look toward discharging that reclaimed water in those cobbles, and those cobbles are useful for decreasing temperature. And then it cools the water naturally, and then it percolates into the surface water, and it's protective of the cold water fisheries that we protect. So next we're going to go into just a couple of case studies that are specific to Western Washington. Just briefly go over them, give you a little bit of flavor of what folks are doing here in Western Washington.
The first one we want to talk about is the Tahale community here in Pierce County. This is an employment-based plan community. It's in between Bonnie Lake and Ording on the Ording Plateau. I'm assuming some of you are familiar with this development itself. The development is planning to have a number of different residences, from multifamily to single-family houses, with a golf course, schools, commercial areas. So this is quite an extensive development that's taking place right now. The development is currently on an existing permit that uses a large on-site septic system, also known as a LOS. As the community develops out, it's looking to build a permanent wastewater treatment facility in order to accommodate all the flows. In this table here, you can see over the next 10 years what we see our flows developing out to. This is our ADF, our average daily flow. We see it going from 0.72 million gallons per day to 2.61 million gallons per day, with subsequent peaking factors due to stormwater and those sorts of things coming into the system. So just a little overview of the treatment process itself. Again, I'm going to reach out to the wastewater nerds here. It's going to be a membrane bioreactor, which is commonly being used both in Washington and Oregon for producing Class A reclaimed water. So we're going to go through a screening process, which is a fine screening process that helps to protect the membranes themselves. In this schematic here, this building is the headworks, which will house the screens. The next we go through is a 4-stage Bardenvo process. I know that's a big word to chew off of. But it's mostly for BOD degradation and for nitrogen removal for our discharge requirements. And these process basins are right here. And then we're going to go into the membrane bioreactor itself, which is a flat plate membrane system that's actually submerged in the wastewater and filters the water right within the basin itself and pulls it out. And the membrane bioreactor is what serves as the tertiary treatment process step that we had talked about previously. And then after that, the water is going to run through this building here and go through UV disinfection. After the UV disinfection, in order to produce Class A reclaimed water, we need to provide Class A disinfection, which will be done with chlorine. And then that chlorine will be used as a residual within the distribution system of the reclaimed water to meet standards set for reclaimed water. And these buildings here, this is a pump station, and this is a reservoir that will serve to distribute the reclaimed water. The reclaimed water will primarily be used for irrigation at Tahale. The next slide I have shows a map of the parks in the area, and right now they're using potable water to irrigate the area. And so being able to use reclaimed water in this valuable resource that they're already going to be producing, they will see substantial cost savings as they run their development. They're going to use the existing irrigation system, which is a pressurized system, and then any excess reclaimed water that they have will go to some ponds on site. This is a map of the development itself. You can see various parks throughout the area. Here's where our wastewater treatment plant will be located, and then from there, we will distribute the reclaimed water to the various parks in all corners of the community, and our overflow will be here at this small pond. And the really cool thing about this system is that if you look at the flows coming out of our wastewater treatment plant through our stages, and then we compare them to our demands that we could have during the summer for irrigation, we see that during some times in the summer, there will be zero discharge. That means that all of the reclaimed water that the plant is producing will go to irrigate the community, and there will be none going to the discharge location. So this is a really cool study to see how we can use all of the water that's coming out, and it's not just limited to a little use here, a little use there, but we can use the total flow that's coming out of the plant. Next, I'm going to turn it over to Mark to talk about King County.
So lastly, I'm going to give sort of a 50,000-foot review of what King County is doing. King County has reused their reclaimed water for quite a while, since about 1997. They have 3 treatment plants that produce reclaimed water and then use reclaimed water for various uses. Brightwater Treatment Plant is probably the newest MBR on the West Coast that generates probably the largest volume of tertiary effluent. So their South plant in Renton generates about 650,000 gallons per day and reuses it for various uses at the plant itself. And then they have at Chinook Bend and Carnation, they have another treatment plant, and they actually use reclaimed water for a wetland facility. Their Brightwater plant, without getting into too much detail, is a very large membrane bioreactor facility that generates about 36 million gallons of a day. It treats about 36 million gallons per day, and at peak flow at about 130. It has a goal of actually recycling about 7 million gallons per day of reclaimed water, ultimately for 21 million gallons per day. And just this year, we were able to actually deliver reclaimed water for the first time from Brightwater to the Willow Run Golf Course for irrigation on the entire golf course. And as they developed their program, now one thing, and briefly, reclaimed water there was at a little bit of a hold because there was active litigation from the water authorities, kind of against the wastewater authorities, suggesting that potentially the wastewater authorities did not have the authority to actually distribute reclaimed water. That has been resolved, and now treatment facilities in Washington can actually go forth and plan and develop and design their facilities. This is an example of a fairly recent study that we completed with the city of Bothell that is looking at distributing reclaimed water to various commercial industrial facilities. About 19 customers were interviewed. All 19 customers were very interested in receiving reclaimed water from the Brightwater treatment plant. And King County continues to develop their program, ultimately to relieve a little bit of their requirement to discharge to the Sound in a tune of about 7 million gallons per day, which is a lot of effluent. So with that, I'll make that quick, wrap it up, and we'll take questions after the panel.
All right. I know our third speaker is anxious to get up here and make his presentation. We have Andy Lucas, who is a vice president with Brown and Caldwell. Andy Lucas, is Brown and Caldwell's wet weather solutions leader. Most of his 24-year career at Brown and Caldwell has been focused on the wet weather practice area. Mr. Lucas has provided leadership on several significant capacity management, operation and maintenance, and asset management projects. So without further ado, Andy.
Good morning, everyone. Thanks, Lorna. So we're going to continue going upstream in the system to the small pipes way upstream. And the title of my talk is sewer system challenges for the 21st century, or if you're broke, why fix it? You'll see why that's important as we get into this topic. We're going to talk about sewer system challenges, drivers for change, challenges facing this change that we want to make, and talk a little bit about some solutions and innovations that we could market eventually. What we're going to talk about mainly is infiltration and inflow. This is water that finds its way into our sewer system for reasons that we can't explain sometimes. It may have been built poorly, the sewer system. It may have degraded over time. Things may have found their way into the sewer system, and basically finding all these pathways for the water to make its way in. And sometimes we have problems in the public system side, and sometimes we have problems on the private system side. And that private system could extend from the lateral, from the connection here all the way up to the home, or just start at the property line. It really varies from jurisdiction to jurisdiction. But what I can tell you is that pipe that's either starting here or starting here up to the house has been largely neglected from the point it's been put in. So really what we're talking about is a sewer system that is out of sight and out of mind. Sometimes it's poorly built. Sometimes it's under attack by the water, soil, trees, vermin that's out there. And it's been asked to do more than what's been intended. So it's seeing all this extra water, this sewer system, and it can't handle everything. And it's also been asked to live beyond its expected life. Many communities, the reinvestment rate that they put into their sewer system is far behind the amount of time it takes for that system to break down. So really, what's the problem? I mean, what we have here is sewer systems that are falling apart. This is a sewer system. This is a lateral discharging into a sewer main, probably at a rate of about 60 gallons a minute. This is a lateral that's made of vitrified clay. It was put in probably in the 1930s. Had very little inspection put into it at that time. And the homeowner, for all intents and purposes, doesn't really care. They flush the toilet, it goes downstream, they have no problems. But you start adding those up, neighbor after neighbor after neighbor, pretty soon the guy at the downstream end of the hill suffers. Now, we can fix things like this. We can fix up the sewer main. This is a sewer main that probably in this general area, it might have been that same lateral, they put in a brand new plastic pipe, and they repaired the first 3 feet of the sewer main. So this is now all plastic, nice, neat pipe. That doesn't leak anymore. But we didn't touch the lateral that extended that next 50, 60 feet up to the house. So we still are left with a leakage of probably 10, 15, 20 gallons a minute. Sometimes the pipe that we built seemed like a good idea at the time. Looking back, it probably wasn't. There was a historic pipe that was used called Orangeburg that was really kind of just made of cardboard. But as you can see here from their advertisement, it's great stuff. But we found it doesn't really last. Trees find a way to permeate their way through there and make a big mess. Speaking of big messes, we also have large storm events that cause all kinds of problems in our neighborhoods. You know, some say that there are increasing frequencies of these large storm events, something that we've been looking at a lot with my client in Milwaukee, what kind of influence it has there. We have damage done around homes, providing additional pathways for water to make their way into the sewer system, which leads to things like this. This was a famous sewer collapse that occurred in a large storm event in 2010 in my hometown of Milwaukee that led to this Cadillac Escalade falling in and was left to just run until it ran out of gas because they couldn't go down there and get it. So some of these are rather extreme examples, but going back to those first couple of pictures of those pipes that leak lots of water, those are not extreme examples. They do happen. There are drivers for changing this situation. We have not these particular folks from the US EPA, but other friends of theirs from the Office of Enforcement and Compliance. We have regulatory orders from states and federal governments that are not satisfied with the performance of the sewer systems that are stepping in and putting in orders on those communities to clean up their act, so to speak. We also have NGO lawsuits that occur, Baykeeper, Riverkeeper, those kinds of folks that are asking for a change to occur. We also have customer complaints. Who here would like a basement backup? No takers, right. So we have people complaining about the performance of their sewer system. They want to see more done. We also have the ick factor, we like to call it in Milwaukee. My client in Milwaukee has done a great job of dramatically reducing sewer overflows to the rivers in Lake Michigan, but they still have them on occasion. A sanitary sewer overflow maybe once every 5 years, maybe two combined sewer overflows per year. They're meeting their permits, they're meeting all the regulatory expectations, but there's still just kind of this ick factor that they have to deal with. And so they're trying to push forward and do further reductions of wet weather flow in their system to improve performance. There's also the aspect of infrastructure sustainability. We have spent a tremendous amount of money investing in the pipes that we've buried underground. And in a lot of cases, they don't leak like those examples I gave you. They're functioning just fine. The problem is the parts that aren't functioning all that well. Sometimes it's hard to find that stuff, hard to fix it, but ultimately, if we are interested in infrastructure sustainability and stretching that dollar as far into the future as possible, we want to try to find those problems and fix them. Finally, I'd maintain to you that good business is equivalent to things that are good for business. Our utilities operating like a business, trying to find these efficiencies, and these are efficiencies that are happening in reclaimed water, happening in extracting energy from these wastewater products, is all part of operating more like a business, and that's ultimately good for business. There are some practical challenges to this, however. One of them is what I call the 80-20 rule. So 80% of the wet weather problems that your sewer system experiences is probably caused by 20% or less of the system. The issue is going out and finding those problems. There's also what I call the 50-50 rule. As we'll see in a moment, about half of the sewer collection system pipes upstream of your wastewater plant are found on private property, or they belong to a private property owner. If you don't have anything in place that would take care of those pipes and stop this water coming into those pipes, you're really only touching half the system. How are you ever going to make progress against this problem in that scenario? Finally, there's not enough dollars to go around. I mean, we'll all agree that it's difficult to get rate increases. It's difficult to stretch that dollar at times. There's always another priority, another regulatory requirement put on a utility. So what are you going to do? And finally, how do I get people interested, particularly if I want to march out there and do something new and innovative, like establish a program to fix pipes underneath people's yards and up to their homes? People don't get real excited about that, especially if it's going to cost them a little bit of money. So now I'm going to tell you a story. This is a story that comes from Milwaukee, Wisconsin, my home state. MMSD, real briefly, is a Wisconsin state chartered agency. They do water reclamation, flood management for about a little over 1 million residents in southeast Wisconsin. They serve 28 municipalities in a service area of about 411 square miles. MMSD, however, only owns 300 miles of sewer pipes. The municipalities that they serve own another 3,000 miles, so 10 times as many. But then those private laterals we were talking about represent another 3,000 miles of pipe. That's the stuff that we're concerned about. It's buried a little closer to the surface. When it rains hard, water gets there much quicker than it does the deeper stuff. It's been built with less inspection, those kinds of things. We're very concerned about its integrity. It's also aging. With very little oversight, it's aging. So this is a map of how the Milwaukee greater area developed over time. That red part in the center was the city center, developed around in the 1850s, and it grew out from there. There are about 300,000 laterals connected to the MMSD system. That's probably got a combined value of somewhere around $2.5 billion, all those laterals added up in terms of what it would cost to fix those things. They also, about 40% of those pipes may also have foundation drainage hooked right into that lateral that brings a lot of extra water into the system. The system's also aging. So in 2014, the amount of pipe that's 75 years old or older is about 28%. But if nothing's done, that's going to increase to 38% in 2034, 57% in 2044, 69% in 2054. You can see what we're up against here if we don't have something in place to address this issue. And that's kind of how they were going about it. They understood the problem, they understood some of the constraints they had, but there wasn't impetus to do a lot about it until there was this major storm that sunk the Escalade in 2010. It caused also about 10,000 basement backups in the greater Milwaukee area. That is a driver for change right there if I've never seen one before. In response, MMSD established a $62 million fund to provide out to its 28 member communities to use for going after sources of private property I&I to help reduce the amount of wet weather flow. It was very clear when they communicated this program, this was not going to solve the problem. It was not going to prevent these basement backups in all storms, but it was really going to help this part of the system that had not been touched before. Each community gets the amount of money back based on how much they pay toward the capital program of MMSD, so there is an equitability aspect to this. And finally, property owners must give permission to participate in the program, but they're not required to participate. They're also not required to pay any money toward the program. So they try to make this with a minimal economic impact directly to the people that were participating in order to give them more incentive to jump on board. And if you want further information, I've given you a website down here called basementconnection.mmsd.com that can tell you more. Well, this started in 2010, and it's intended to go out to 2020. That's $62 million. What's been accomplished so far? Well, so far about 2,000 laterals have been lined with cured-in-place pipe. Another 12 have been replaced, and that number is growing every day. One of the communities decided they wanted to try grouting, which is basically injecting mortar around these pipes for the first 5 feet of the lateral. And that, a lot of times that lateral, that first 5 feet, runs underneath a leaky old storm drain. And so there's been pathways that have opened up over time, allowing that storm drainage to make its way into the sewer system at that point. And they've been grouting like crazy in this one community. They've done 3,000 so far. They've also been disconnecting foundation drains. And here's some pictures of some of the work that's been going on. The other thing they've been doing is trying to bring results. So it's not enough just to shotgun spend this money all over the place. If this money is going to continue to be there into the future, they have to bring results back to the decision makers. And so one of the things my company has been doing is been working with them to help focus the spending of this in certain areas where we can monitor flow information in the system during storm events and detect the amount that it's been reduced as a result of this work and bring answers like this. So these are model simulations we're using here, but it's saying in this kind of storm event, the peak flow rate after all this work's been done in a given area was reduced by 62%. And that cost about $1.22 per gallon per day of peak flow to remove from the system. Now that means something if it costs you to build $5, $6, $7, $8, $10 per gallon per day to, let's say, pump that extra flow through the system or treat it at some place downstream. We also bring statistics like, the once in 5 year peak flow event will be reduced 46% at a cost of $1.58 per gallon per day. These become now very meaningful pieces of information for decision makers on whether this makes sense to invest in the future. So that kind of tells a story about the Milwaukee program. Now I want to leave you with a thought about how we can innovate for the future. I'm going to maintain that we've got choices. We can either fix stuff right or fix the right stuff. And when I say fix stuff right, I'm talking about what I call the broken risk transfer model. And it goes like this. An owner has a problem in the system and they commission a study of their problems in the system. An engineer goes out and performs that study. I have been that engineer myself. The engineer then goes out and designs improvements to the system to reduce the flows in the system. A contractor is hired at lowest bid to go out and build those improvements to the system with the hope of reducing the flows. However, the system problems persist because all along that risk has been transferred from entity to entity to entity with no one really having any skin in the game for what was an interest in the end, which was to reduce flows from the system. At the end, our ratepayer is stuck with the bill each time because things really have only improved marginally, but lots of money has been spent along the way, and we keep getting the question, why are we doing this? I think I heard that before. Why are we doing this? So what I want to offer is a potential innovation for the future for contracting, I think, in the wet weather area. I call this the innovative risk transfer model. System problem is identified. Owner and engineer together determine the value of reducing flows in the system, kind of like that cost per gallon per day of peak flow I mentioned before. An owner then advertises an RFP for a public-private partnership sort of construct for flow reduction. So my time's up. Then the contractor submits a bid to reduce flow for a fixed price. Then a contractor performs those improvements, and then a engineer determines the actual flow reduction as a basis for payment. Now, this is kind of a scary construct. Not many contractors would sign up for this today, but there has been one example a number of years ago from Nashville, Tennessee, where there was at least a bonus payment placed on a contract for sewer rehabilitation, and that bonus payment was contingent upon first meeting a minimum level of flow reduction, and then after that, a bonus would kick in at certain points of additional flow reduction that was achieved. So I think it is possible to do this, and I want to put that out there because I know this is a business-oriented and very innovative-minded crowd to hopefully spur some more interest in this down the road. So that's my presentation.
Okay, thank you. Those are really interesting. So I think we're open for some questions. Okay, there's one. Carol. Oh, I actually know this person here.
I'm Carol Parvey. I'm with City of Fife now. And I have a question for Chris and Mark. I was wondering how you price the reclaimed water when you